Welcome, this is Mr. Harper Smith. Today we're going to be talking about the chi-square formula. Now, oftentimes when you see it written, it won't be written as nice as this. You might want to write that down. It'll usually be written more like this. OI minus EI squared divided by EI. The O stands for observed value. The E stands for the expected value. Okay. The I's represent each of the categories. So you do this formula however many times there are for however many categories. Basically is what's happening. Okay. So let's use an example. Let's say that there's a street race going on, and so you're expecting a whole bunch of cool cars to show up. Out of the Fords, there's three types of Fords that you're expecting to show up for this street race. You're expecting some Mustangs, you're expecting a couple of Focus STs and a couple of Fiesta STs. Just, a couple of Fords that should be showing up. You know how many Ford made of each of those, and so you break it down, and you're expecting, out of all the Fords to show up, for there to be about, 157. So you're expecting 157 Fords. Okay, you're expecting 157 Fords to show up to this street race. All right, well, but in reality, here are some of the real numbers that we got. We were expecting 30 Fiestas, 25 Focuses, 102 Mustangs, but we really got 28 Fiestas, 31 Focuses, and 73 Mustangs. Were we off? Was our data off? Well, in this case, we can use a chi-square test. So here's how it works. You do the observed minus the expected divided by the expected for each of these. So the observed, 28, minus the expected divided by the expected. Okay. The observed minus the expected divided by the expected after you square it. If you notice, the top always ends up being positive. Ooh, interesting, tricky. All right, the focuses, we've got 25 minus 31 divided by 30, square the top. The bottom, we've got, let's see here, oh, I did that one backwards actually. It should have been 31 minus 25. And the last one is 73 minus 102 divided by 102. Square the top. Well, we do this, and that'll give us 4 divided by 30. Here we've got 6 squared is 36 divided by 30. And here we've got, what would that be, 29 squared. That's gonna be a big number. 29 squared is 841 divided by 102. Technically there should be a sigma here. It's the sum of. So 4 divided by 30 plus 36 divided by 30. That should be 25. Okay. Plus 841 divided by 102. And we get a score of our chi-square is 9.57. That is this chi-square for the statistic, for this set of data. All right. Hold on, this isn't straight. There we go, okay. So let's do another test. In manufacturer, they're making paper plates, and they make red, blue, and green plates, and they sell them as a pack. So you can buy a party pack of 60 plates, okay? Has a couple of all the colors. And they're claiming that you'll get 20, 20, and 20. So you should get 20 reds, 20 blues, 20 greens. Well, we go out, we buy a pack, and we get 18, 23, and 19. Should we be mad? Do we have enough data to show that they did this incorrectly, or are they statistically close enough that they're fine? Let's do a chi-square test and find out. All right, observed minus expected. So we get our 18 minus 20 over 20 squared. We have 23 minus 20 over 20 squared. And we have 19 minus 20 squared over 20. Remember, our answers, we're going to add them all up. So the top, we get 4 over 20. Here we've got, let's see, 3 squared would be 9 out of 20. And here we get 1 out of 20. Okay, because 1 squared is just 1. All right, let's add them together. 1 plus 9 is 10, 14, so we get 14 out of 20. That would be our chi-squared statistic. Okay, that is our chi-squared statistic. Chi-squared statistic. I'll do one more. If you need to watch it, great. If not, you can pause the video and try the problems down below. All right, here's the last problem. I love shopping over at H-E-B. They're, the almond and peanut butter bars, they're pretty good. I really like them. Well, they always claim, and it says it right on the box. I'll show you the box here. The box says they're going to give you 24 almonds and 18 peanuts. Okay. What if I like the peanuts more? No, it doesn't matter. So this last time I got the box and I counted, and there were actually 19 peanuts and 23 almonds. Is that a problem? Statistically, is that a problem? I want you to go through and calculate the chi-squared statistic. The chi-squared statistic. Pause the video and do it. All right, you should have paused the video. You should have the answer by now. Let's go through and do this. We've got 19 minus 18 squared divided by 18. Then we have 23 minus 24 over 24 squared. Well, that gives me 1 out of 18 and 1 out of 24. I'm too lazy to make those variables the same. So we've got 1 out of 18 plus 1 out of 24. That gives me 7 out of 72 is my chi-square statistic. Try the problems down below.